He's not a god. He's not bitten by a radioactive spider. He's just a man. A man with a brilliant mind, unlimited money, and an addiction to solving problems with tech. That's why Iron Man is different. Because deep down, Iron Man isn't just fantasy. He's a blueprint for what might be possible. DARPA's developing powered armor, jetpacks are real, AI co-pilots exist. But how close are we really? In this video, we're going to reverse engineer the Iron Man suit, one system at a time, and see just how far reality has caught up to fiction. Let's start with the heart, the Arc Reactor. In the Marvel universe, this little glowing hockey puck-sized technology produces 3 gigajoules per second. That's more energy per second than a nuclear aircraft carrier produces at full steam. So could we build one? Short answer, not even close. Longer answer, maybe with fusion. Right now, we're trying to contain superheated plasma with magnetic fields to trigger controlled fusion, the same process that powers the sun. Projects like ITER and Helion are making rapid progress, but even the smallest experimental fusion reactors are the size of a house. So maybe it's not fusion, maybe it's next-generation batteries. We're talking solid-state lithium, graphene capacitors, aluminum air cells. These could power exosuits, drones, even electric aircraft. But none of them pack the kind of power needed to run an Iron Man suit, at least not yet. And even if you could generate that much power, that energy has to go somewhere, and you would cook yourself inside that suit before liftoff. But it does force the question, how far are we from powering the impossible? The exosuit. It's the iconic Iron Man look, sleek, fast, armored like a tank, and yet somehow flexible enough to move like a gymnast. Real powered exosuits do exist, but they look more like forklifts strapped to your legs. Lockheed Martin's HULC can help soldiers carry 200 pounds, or around 91 kilograms of gear. DARPA's been funding military suits for over a decade. Sarcos Robotics even built a full-body exosuit for industrial work. But they're slow, they're heavy. They rely on tethers or massive battery packs, and nobody's zipping through the sky in an exosuit. The movie suit seems weightless, but in real life, even if we used ultralight materials like carbon fiber composites or titanium alloys, a full-body armor system could easily weigh more than 450 pounds or more than 205 kilograms. That's like carrying 2 people on your back, while running, jumping and flying. Engineers are experimenting with smart materials that can change shape, self-repair, or harden on impact. Imagine a suit that flexes when you move, but turns rigid when you get hit. That's real, and it's being tested in labs right now. J.A.R.V.I.S, what's the status of the suit? Sounds like magic, right? But the truth is, we already have AI that listens and responds like J.A.R.V.I.S. ChatGPT, Siri, and Alexa can process natural language and respond in real time. But J.A.R.V.I.S is different. It's not just chat, it's a full combat co-pilot. Imagine an AI that monitors vitals, scans the battlefield, controls targeting, predicts threats, all while talking to you. The US military is already testing AI-assisted targeting systems, real-time augmented reality overlays, and even augmented pilot helmets. Iron Man's iconic heads-up display. It's basically an F-35 pilot's helmet multiplied by 10. And guess what? It costs around $400,000 just for the helmet. Combine this with computer vision, object tracking, and speech synthesis, and we're already building systems that could talk, see, and react like J.A.R.V.I.S. Now add brain-computer interfaces like Neuralink, and suddenly you're not just talking to the suit, you're thinking with it. But the core idea? A responsive, adaptive AI partner with real-time sensory input and tactical control. We're not decades away. We're building the prototype right now. Let's talk about the most impressive feature in the whole suit: flight. Iron Man doesn't just hover. He can do barrel rolls, dodge missiles, and pulls G-forces that would black out a fighter pilot. Human flight is real, Jetman Dubai uses carbon fiber wings and mini-jet turbines. Gravity Industries built a jetpack that straps turbines to your arms and lets you fly. The real question is, could repulsors on the hands and feet work? In terms of physics, it's irrational. Keeping stable with multiple thrust sources while changing direction, avoiding torque spin and aiming your weapons, all but impossible. Even NASA's tried full-body flight rigs. They're wildly unstable. Our bodies just aren't designed to balance with thrust coming from our limbs. Not to mention the heat from those repulsors would burn your legs to a crisp. And if you're pushing Mach 1, you just smashed your organs into the back of your ribcage. Experimental plasma propulsion, magnetohydrodynamics, even directed energy thrust. They're all on the drawing board. We're not flying Iron Man style yet, but we are flying. And the line between human and machine, it's getting thinner by the second. Flying's one thing, but Iron Man doesn't just fly. He fights. Repulsor blasts, guided micro-missiles, shoulder cannons, laser weapons. It's like a Pentagon budget inside a briefcase. So, can we actually arm a suit like that? Let's start with micro-missiles. In real life, miniaturized munitions do exist, like the Switchblade drone or LMAM's lethal miniature aerial missile system. These things are the size of a loaf of bread, and they can lock onto targets from over a mile away. Could you strap them to your shoulder? Technically, yes, but good luck surviving the recoil. What about repulsors? The closest real-world equivalent would be plasma-based weapons or electromagnetic railguns. Problem is, they're huge. They need a nuclear reactor to power them, and you definitely don't want one strapped to your wrist. Laser weapons are real too, and used to shoot down drones and missiles. But condensing a directed energy system into a gauntlet, that's not happening unless you completely redefine physics. Now let's talk defense. Tony Stark handles bullets, explosions, EMPs, and space vacuum, all without flinching. Real armor can stop bullets. Reactive armor can even disrupt incoming rockets. But protecting a full human body without sacrificing mobility, that's still a huge challenge. Engineers are testing next-gen materials, such as graphene composites, shear thickening fluids that harden instantly on impact, and even metamaterials that bend electromagnetic waves. These might one day create adaptive armor that changes its properties in real time. The real challenge isn't just building the weapons, it's fitting everything, power, cooling, targeting, recoil control, into a suit the size of a human. Right now, you'd probably fire once and your arm would snap like a breadstick. But make no mistake, the tools are emerging. AI-assisted targeting, wearable drones, adaptive armor. We're not just imagining this anymore, we're engineering it into existence. But for all the genius behind the suit, there's one glaring flaw in the Iron Man design: the human inside it. Muscles fatigue, lungs need oxygen, brains black out under pressure. The human body is shockingly easy to destroy. So what if the future Iron Man isn't human at all? We're already building machines that run, jump, shoot, and think faster than we do. Add autonomous targeting, adaptive learning, self-repairing code, and you've got something that doesn't just wear the Iron Man suit, it becomes it. But ask yourself, if Iron Man of the future isn't human, who decides what it fights for? Who does it obey? And when it decides to do something, does anyone get to say no? Thank you for watching. If you found this video insightful, don't forget to like and subscribe for more thought-provoking content. Only on Cretonium.